So an extension of Le Chatelier's principle deals with the relationship between our equilibrium constant and temperature and what we can tell about the energetics of an equation or reaction based on its equilibrium constant at a variety of temperatures. So let's think about this one. Or let's clarify first. Temperature is the only thing that's going to change Kc. So changing the pressure, adding or removing reactants and products, the presence of catalysts, they do change the position of equilibrium. They do not change the equilibrium constant value. So that's correct in your notes, but it's not correct on the PowerBoard. There you go. So if we look at Kc values for various temperatures, you can then know if a reaction is endothermic or exothermic. Okay, so scenario number 1, an exothermic reaction. So we have A plus B yields C and heat. So if we add heat, if we raise the temperature, we're going to shift that reaction to the left, which means we'll produce more reactant. Well, if we think about our equilibrium expression where we have product over reactant, we're making our denominator larger and larger, which means our values will decrease. Our Kc values decrease as temperature increases. If we deal with an endothermic reaction, it's the opposite. So adding heat will shift the reaction to the right. We're making our numerator larger and larger, so our Kc values will increase. So let's try a couple of problems. Okay, what is the effect of increasing temperature on this equilibrium? Okay, so we have our equation and delta H is negative, which means this is exothermic. Okay, so if I think about it, here's heat as a product. So if I increase temperature, I'm adding in a product, that's going to move my equilibrium away from that. It's going to shift it to the left. Okay, so I'm going to cross out C and D because those can't be correct. I know it's got to be either A or B. Now I've got to think about the second part of this, the Kc. Well, if I'm making my denominator larger as I'm shifting this more and more to the left, Kc will decrease. So A is the correct answer. Well, let's try a slightly different version. Okay. Which equilibrium shifts to the product side when the temperature is increased at constant pressure and to the reactant side when the total pressure is increased at constant temperature? Okay, so we have two different things that we've got to deal with here. Let's just deal with the first one. We're looking for something that will shift towards the product side when the temperature is increased. So if it shifts towards the product, it shifts towards the right when we add in heat. That means that this reaction must be endothermic, where delta H is positive. It's greater than 0. So I'm going to cross out my ones where delta H is negative. Okay. Now I'm going to deal with the second part. Something that'll shift to the reactant side when the total pressure is increased. So if increasing pressure shifts towards the reactants, and these are all gases, that means I've got to have fewer moles of gas on the reactant side. So I look at B and D. B, I have 1 versus 2. D, I have 2 versus 1. So it's going to be B to shift towards the fewer moles of the gas. So there you go.